Good day everyone. We are here to discuss the data encryption standard process of convert to bits, initial permutation, expand right, XOR subkey, substitute, permute, XOR left, rotate halves, left 1, and last but not the least is extract bits. Convert to bits. In the convert to bits, it's simply to convert the plain text input key input and ciphertext output into binary. Here are the example on how to convert bits. For example, what is the binary of 1? It is 0001. How about 2? The binary of 2 is 0010. That would be the result in convert to bits. Next is the initial permutation. In the initial permutation is based on the initial permutation matrix where all rows and column numbers include the initial permutation matrix can be seen at the top. Above, you can see the indicated numbers 1 to 64 and every number has a specific value or binary that can be seen in the result of convert to bits. For example, 54, which is the first number in matrix and its initial permutation is 0, that can be seen in the convert to bits. Expand right. In the expand right, take the right half of initial permutation, then you replace his bits instead of 33 to 64. Replace it into 1 to 32. Then look for list EBIT selection table matrix. Now, all the numbers in the matrix have its assigned values or binary. They're in the yellow line. After you get all their assigned values or binaries, you can now arrange it in one line. Then you already have your expand right result.
What is XOR left? XOR stands for exclusive OR. As can be seen, the output values of XNOR are simply the inverse of the corresponding output values of XOR. XOR is also used to detect an overflow in the result of assigned binary arithmetic operations. If the leftmost reading bit of the result is not the same as the infinite number of digits to the left, then that means overflow occurred. XORing those two bits will give a 1 if there is a overflowing. The primary reason of XOR is so useful in cryptography is because it is perfectly balanced. For a given plaintext input 0 or 1, the ciphertext result is equally likely to be either 0 or 1 for a truly random k bit. 4 important properties of XOR. One is commutative, associative, identity element, and self-inverse. Commutative this is clear from the definition of XOR. It doesn't matter which way round you order the two inputs. Associative, this means the XOR operations can be chained together and the order doesn't matter. If you aren't convinced of the truth of this statement, try drawing the truth table. Identity element, this means that any value XORed with is left unchanged. Self-inverse, this means that any value XORed with itself gives 0. These properties hold not only when XOR is applied to a single bit, but also when it is applied bitwise to a vector of bit, example, a byte. For the rest of this article, I will refer to such vectors as bytes because it is a concept that all programmers are comfortable with, but don't let that make you think that the properties only apply to a vector of size A. How does bitwise XOR works? XOR bits is a bitwise operator and it stands for exclusive OR. It performs logical operation. If inputs bits are the same, then the output will be false 0 else true 1. What is rotate halves left 1? There are 180 degree in a half turn. When it's come to rotation, if we rotate an object one full turn, then the object will have rotated through 1. Reversal of direction, as in a staircase, either by 180 degree turn or 2 right angle turns. An example where rotation representation is used is in computer vision, where an automated observer needs to track a target. Consider a rigid body with their orthogonal unit vectors fixed to its body or representing the 3 axes of the object's local coordinate system. The basic problem is to specify the orientation of these 3 unit vectors and hence the rigid body with respect to the observed coordinate system regarded as a reference placement in space. What is extract bits? The extract bits blocks allow you to output a contiguous collection of bits from the stored integer value of the input signal. Use the bits to extract parameter to define the method for selecting the output bits. This is the block outputs, a contiguous selection of bits from the input integer number. The bits extract defines the method by which the user select the output bits. 1. When upper half is selected, the block outputs the half of the input that contain the most significant bit. In this case, the third parameter number of bits or index of bits is ignored. 2. When the lower half is selected, the block outputs that half of the input that contain the least significant bit. In this case, the third parameter, number of bits or index of bits, is ignored. When range starting with most significant bit is selected, the block outputs certain number of bits of the input that contain the most significant bit. In this case, the third parameter, number of bits or index of bits, defines the number of bits to extract. And lastly, when range ending with less significant bit is selected, the block outputs certain number of the bits of the input that contain the least significant bit. In this case, the third parameter, number of bits or index of bit, defines the number of bits to extract. When range of bits is selected, the block outputs a range of bits of the input. In this case, the third parameter of bits or index of bits define the range of bits to extract. It must be a vector with the formal or start and the extract value depends on the fourth parameter. Treat bits fields as an integer. When it is set to 0, the input is used to determine the output is calling. When it's set to 1, only the extract bits form the output number.
XOR subkey. XOR, a Boolean logic operation that is widely used in cryptography as well as in generating parity bits for error, checking, and fault tolerance. XOR compares two input bits, generates one output bit. The logic is simple. If the bits are the same, the result is 0. If the bits are different, the result is 1. Subkey are created from the original key by a key expansion algorithm designed for multiple round cipher called a key schedule. A popular method of combining a subkey with data is bitwise XOR. In each round after the key mixing, the data is scrambled further using substitution and permutation function. Substitute the 48-bit block to X box. Substitution is divided into 8 blocks of 6 bit each, and it's provided as input 8 substitution boxes, all called X boxes. Each X box has an input of 6 bit and its output 4 bits. Each X box is considered as the table which has 4 rows, 0 to 3 and 16 columns. Why 4 rows and 16 columns? Because from the 6-bit input to X box, the two extreme bits are used to determine the number of rows. Two bits can form 4 combination of 0s to 1s. The middle 4 bits are used to determine the number of columns, which is 16 columns. Now, we will see how the 6-bit input the transform to the 4-bit output. For example, in the figure above, you can see that input bit at position 1 and 6. 10 that represent 2, which determines second row, and middle 4 bits 0, 1, 1, 0 that represent 6, which determines the 6 columns of X box. The value at the intersection of the second row and 6 column will represent the 4 bits output of corresponding X box. In our example, the intersection of second row and 6 column is 13, its 4-bit representation is 1101. So the output of X box 1 is 1101. Permute. The 32-bit output obtained from X box substitution is provided as an input to P box here. The 32-bit input is simply permute and sent to the next step.